Yes.
Okay, right. So today we'll continue. I think last week we finished the chapter 3, right? We finished chapter 3, right? The building block of Python data structure, function, and files. And this chapter is really condensed in the sense that it touches and discuss many concepts. If you have not read it, you follow up and read the chapters. Yeah, and today we will continue the next chapter, which is Numpy. So now we built our background in Python, data structures, and IPython. Now we'll start looking at the component that can be used for data analysis. The first thing we will look at is Numpy array. So let's look at Numpy array. So what is Numpy array? So it's basically when you say Numpy, it means numerical Python. Numerical Python. So what this means is if you want to do numerical stuff, calculations, and multiplication matrices, all addition, and you want to do linear algebra, you want to do sai kuma me ake yi a maths irin wannan abubuwan bayan su linear algebra, calculation of matrices, and all those stuff, then the efficient way to do that is through what we call NumPy. That is why it is called numerical Python. Python normally, so if you are using web programming, you don't need Python because you are not doing numerical, you are not doing calculation, finding the course, all those stuffs. If you are building applications, you need Django and those stuff, you don't need NumPy. But if you want to do scientific stuff, you need NumPy in Python. More or less, you have in MATLAB, where we have, you can do those kind of, if you remember, I think some of us will remember in your CS, we did MATLAB. In MATLAB, you do matrix multiplication, you do in your computer graphics. So in Python, at its base, it does not support this kind of optimized numerical calculations. You need to install a library to do this kind of numerical calculation. That library that is used in machine learning and data science is called NumPy. So that is NumPy. So NumPy provide a lot of stuff. Array, we know array, right? In mathematics, it provides mathematical functions like cos, sine, sum, addition, all those functions NumPy provide. It provides tools for writing and reading, how to read. It provides tools for linear algebra. So in linear algebra, we can do matrix multiplication. We can do a lot of stuff. We can do eigenvalue, eigenvectors, all those stuff. And NumPy provide API to connect to C++ and Fortran. So you can also do C++ and C++. You can do NumPy operation, or through Fortran, you can do NumPy. So in a nutshell, what is NumPy? NumPy is basically, you remember we said, though Python comes what we call batteries included, it comes with a lot of stuff, but at its base, it does not come with NumPy. You need to install NumPy. So how do you install NumPy? We already know how we can install stuff. So if you don't have NumPy, what you need to do is you do this Quanda. So we can do Quanda. No, why this? Or if you are familiar with pip install NumPy, you can install it, or Quanda install, that will install NumPy for you. So if you don't install NumPy, you can go and install NumPy. We all know how to install package, right? So if you don't know, you can come here, how to install NumPy, We all know you can use so you can come here and see if you are using Windows. So look at it. As I told you, we need to sometimes create our environment before we do installation. So here we all understand what is Conda create minus n it create environment here. And now here we activate the environment. And now here I set Conda to be the default for installing on my package. And now I install NumPy instead. So you can see Conda install NumPy. If you are using pip, you can say pip install NumPy. So that is NumPy, and that is how we can install NumPy. Any question before we continue?
Yes, Doctor.
Yes.
Which environment is it creating?
Ah,
for data science ko shi ma NumPy yana da wani environment.
Okay. No. So not that. So for your environment that you can use for machine learning, the same environment. So what that means is that if you don't have the environment already existing, so yeah. So what we are saying here is this. So you can see here, if you look at my screen, I have an environment that already create called data science in my stuff that I installed. So since I am inside my environment, that I can just say Conda install Conda is. Oh. No, I don't need to create environment. This is
install.
Yeah, Conda. I can say Conda install. Oh, my computer is so slow. So I can just say Conda install Numpy. Yeah. So the reason why they show there that you need to create environment is that if you don't have an existing environment, yes. So yeah, if you don't have existing environment, it's better to create a new environment and install all your stuff there. But you can even install Numpy without creating environment, but you are installing the Numpy in your bare Python in your computer. Kamar misali yanzu a tsakar gida kawai sai ka zo kai abin da ka gama. But if you have like rooms where you do a lot of stuff in one room, you can go to that room and install Numpy. You go to the room to install pandas. You go to your room and so that you have specific stuff in kowane room if you want to do data science, if you want to do, so that's it. But this is not necessary, but it's recommended to create environment and install your packages there. Yeah. So for example, now if you want to do deep learning, you have PyTorch, maybe you need to create a separate environment that with PyTorch, and you do all those your environment for, I mean, the environment is created normally for a project. So for example, now, if you are going to do project this year, so you create environment, you specify the Python, all the version you are using, and now you work your project. So maybe you want to share your project with another person. So you tell him that you can share everything, the package environment, because maybe he's not using Python 3.10 that you are using, he is using Python 3.9. So if you gave him the your package, your environment, he knows what you are doing, what you install, and he can install them. So this is the same thing what we discussed on environment. Yeah. Any question before we continue? Any question? No? Okay. So yeah, so what this will cover, this chapter basically is we will see fast array based operation, how we can do array operation like subsetting and stuff like that, common array algorithms like sorting, unique, all NumPy provide this. So you can do this. We can do aggregation, we can do alignment, a lot of stuff. So these are some of the stuff this book will cover. We will go through all of them to see what we do. And also one thing you should know is that this great NumPy, it really provides a computational foundation for general numerical data processing. Even pandas, was also at the bare bone, pandas is using NumPy. So NumPy is basically provide a foundational for numerical data processing. So when we come to pandas, we will see like a lot of other stuff from pandas. They are also from NumPy. So that's what this guy is saying. NumPy provide computation for the general numerical data processing. Many readers will want to use pandas at the basis for most kind of statistics or analytic, especially on tabular data. So pandas also provide some domain specific functionality. So some people will try to see they use pandas for some other, but NumPy is the general, and yeah, so we see a lot the difference between them. So here, why NumPy is important? I already mentioned this. NumPy basically provide a faster and efficient way to do some mathematical operation. And yeah, for example, let me show you one of the great example. So here, let me show an example why NumPy is important. So, okay, let me clear this guy. So let me run this guy. I import NumPy. So here I import NumPy and as NP. So you will be seeing some people import NumPy. When you see import NumPy, it is always, we already know what does that mean. So this is how we always import NumPy. Now I'm creating array here. So since I say NumPy, import NumPy as NP, here you can see I can say np.arrange. Means inside Numpy, I have a function or a method called arrange. Here I'm creating an array of 1 million variable inside it. So this is using Numpy. Now here, remember, this is a range. We have a range of 1 million. And now this range, I'm converting it to list, right? This is a Python list. So when I run this guy, you see what this means. So you can see this. Let's look at how Numpy arrange looks like. So this is, yeah, so this is the Numpy array. You can see it's array from 0 because I say 1 million. You remember, so arrange in Numpy, use arrange. In Python, we use range. Remember, we all know what range means, right? So range, arrange is equivalent to range in Python. So this is Python. For those that forgot what range is, so if I use this guy, I say range of, I put 5 here. So when I say range, what basically it does is give me a range of numbers, right? So you can see here, it starts from 0 to 5. The 5 is not included, but when I call list on it, I can see that this is what this guy gives me, right? So when I call list on this guy, so we can see this is, yeah, so you can see range, it means it's defined 5 numbers, but 5, the last number is not included, but range start by default. If we don't provide the starting, it start from 0. So 0, 1, 2, 3, 4, 5. So, but in Numpy, we arrange is the same thing, is equivalent. So take note of this. So you can see here we have arrange from Numpy, and let's look at my list from Python built-in. What is the meaning of this? So when we look at this guy, we can see that this is what this guy means. Right, so you can see it's like giving us from 0 to 999, it will give us this. So you can see here, you can see it out to the end. So they are basically the same thing. What we want to show here is what is the actually the performance. How long does it take Python to create this 1 million lists? How long does it take to create this? Because this is Python list, mere Python. This is Numpy. Let's look at the performance between the two. So now when we run this, this is a function. This time is used to find the time of execution. So this timing will count the time it takes to actually do this. What I'm doing here is that I'm multiplying each number here by 2. So each number inside this 1 million, I'm multiplying it by 2. Can you see that? My array by 2. I store in my array, right? And so here I do this thing. I loop. So here also. So what we can see here is that the first one, because we are using my array, which is from Numpy, it took like 26.8 milliseconds. The system 17.3 millisecond, total 4.4 millisecond. But you look at the CPU time for a built-in Python list, it takes 1.37 second. Can you see that? But this one is millisecond. This one, can you see 384 millisecond, but there's 17 millisecond, 441 millisecond. This is 1.7. So the main idea here is this, nothing much, that Python is slow. We cannot afford to use Python to do like machine learning, like deep learning with 1 million rows. You know what I mean? So how can we optimize the performance of Python? Python naturally is slow. Yes, it's slow. Or like C++, which is fast. So now to complement this slowlessness of to complement this slowlessness of Python. Slowlessness. Slowlessness. Kace kaje makarantar abin nan kenan. Makarantar Lilo kaje. So yeah. So yeah. So to complement these sluggish features of Python, then Numpy is created. So you can see Numpy is faster. So everything, if you want to do, though of course you can do some kind of mathematical operation and other stuff in Python, but it's slow and we need to optimize it. So that's why we Numpy. This is one of the advantages. So Numpy-based algorithms are generally 10 to 100 times faster than their pure Python counterpart and use significantly less memory. So you can see this is impressive, right? Because it's used less memory and it is faster. So that is one of the motivation of using Python, NumPy. Any question before we continue? Any question? Okay, so if there is no question, we will start looking at some of the things that NumPy provide to us, right? So one of the things Python provide to us is an array, a multidimensional array object, all right? So we all know that in Python, we use list to store objects, we use tuple to store object, but in mathematical, we use array to store a large number. So here, one of the key features of NumPy is its n-dimensional object, or ND array. So when you say ND array, which is fast, number one, flexible container for large data set in Python. So if you have data set which is very large, don't store it in normal Python, in normal base bare-bone Python, because it is slow, it will consume memory, because it's not actually optimized, because NumPy is flexible container and optimized. So arrays enable you to perform mathematical operation on whole block of data using similar syntax equivalent to scalar. So that is one advantage of also on NumPy. You can do what we call vectorization. So let's look at how we can use NumPy. Import NumPy as NP. Remember, I already installed NumPy on my computer. If you don't install NumPy, this will not work. So let me generate numbers. So NumPy has a lot of functions. So for example, here you can see I say import NumPy. What I'm doing here, NumPy has what is called random function. So you remember here, NumPy is a module, right? I mean, NumPy is library. Inside there are many things. So we have random module, and in the random module, you can see what is it. Use it create generator called method. So what this random module basically does is that it just generates random numbers, right? So for example, rand uniformly distributed value, rand n normally distributed value, rand f uniformly distributed floating point number, random integers, you can see random sample, radian seed. So under random, there are different functions. Can you see now here I call rand n? So what rand n does? So rand n, you can see here, it basically returns sample O from sender normal distribution, So we know what normal distribution is. It sends from 2 to 3, given 2 and 3, return numbers, random numbers, normally distributed. So when we run this, yeah, so you can see here we have numbers, right? So you can see here we have 2 by 3 array. You can see this is 2 by 3 array, right? So we can see this is it return numbers in this. So this is what we call array, Python array. So yeah, so one good thing with that, you can do what is called vectorizations. For example, if I want to multiply each number with 10, you can just call your data, your array, and say multiply by 10. This, you know, in Python, we need to implement use for loop, right? For loop to, it will multiply this number, multiply this number, multiply this number. Remember for loop, or what we discussed last, what do you call it? Not for loop. What do we use in for loop? Remember the substitute of for loop, the efficient way, what is it called? List comprehension, right? So if I want in Python, if I want to multiply each number, I need to go through implement for loop or use comprehension. But in NumPy, it comes with what we call vectorization. That is, if you multiply one item, this by the same by your array, it will multiply each number. So let's look at what this means. So here it means it multiply, each number is now multiplied. You can see that this multiplied by 10, this multiplied. This is what we call vectorization, right? Also, you can do addition. When I say data plus data, this I'm adding this, then each component will be added by each component. That is, now I'm adding 2 components. Therefore, this one will be added because it's data. It will be added by another data. You can see minus 0.204 plus minus will give you this, right? So this is some of the small stuff that you can do with NumPy, which this is not, you cannot do this in Python, normal Python, right? And also because we want to do some kind of mathematics, you remember NumPy comes with a lot of functions that you can do that. So if we see like this, we can say NumPy NP dot. Now, when we say dot here, we will see a lot of function method that we can use. Can you see tan? Can you see a lot of stuff, some that you can do basically? Can you see many stuff, you know, a lot of other stuff that you can use with NumPy. So yeah, a lot of mathematical stuff that you can do with that. Yeah, so that is it. So any question before we move on? Okay, so an ND array, when we say ND array, we mean multidimensional array or numpy array, is used for storing homogeneous data. When we say homogeneous data, it means data of the same type. All elements must be of the same type. Yeah, every array has a shuffle. So if you look at this one here, we have of the same time numbers. Double, you cannot put like string, like in a list where we have string, we can put string and integer and double, you know. Array is homogeneous data structure. That is, everything is is contained there. And one thing we should know with array, so remember we are still discussing about NumPy, and array is one of the most important data structure in NumPy. That is why we started discussing it. And for each array, it has two things. It has a shape and it has a data type. Now we have our ND array here called data. If we look at this one here, yeah, look at it here, right? Now, you can find the shape of this using this dot shape. So remember, this is not like this, a method, right? This is not a method. Remember, we have a method, we have an attribute, right? So this shape is an attribute. If you remember how we do classes, those without braces, without this, they are attribute of that object. So shape and D type are attribute of attribute. So when we run this, this will give us the shape of this. So you can see this is 2 by 3, right? So you can see this is 2 by 3, right? 2 by 3. Here we have this, and we have this 2 by 3. And now we have what is called data D type. So this D type is what we mean by data type. So this is called D type float 64. Float, something like that. So float. So every array, every NumPy array, ND array has these features: the shape and the data type. So we should know which kind of data type our array contains, and we should know the shape. For you to do that, you do this. And whenever you see array, NumPy array, ND array in this book, in most cases, they all refer to ND array. So whenever you see, we say NumPy array or ND array or array, they basically means ND array. Yeah, any question before we continue?
Sure.
Yes, Adja.
Na'am, data type din nan koyaushe 64 ne ko suna da, it depends on yadda mutum ya
Yeah, so
na ga kamar 32.
Yes, exactly. You can get 32 in some cases, right? So we will see it in a bit. We will see what this means. So this is 64. It means is what we call is 2 byte, right? Yeah, 2 byte representation, right? We'll see that in a bit. Yeah. About this stuff. Thank you for the question. We'll come to that. So using how to create ND arrays. So how do we create ND arrays? For example, we know how to create a list, right? For us to create a list, we can use this guy. We say, okay, list of these numbers, right? This is how we can create a list, right? But also we know how to create a tuple, right? So for us to create a tuple, we use this guy and say, okay, this is how to create a tuple, right? We all know this is how we create a tuple, right? Also for create a set, we can use this keyword. For us to create a dictionary, we can use this dict, right? We all discussed this, right, in our previous session, right? So how do we create an array? So for you to create an array, first you need to import NumPy, right? You say import NumPy, NumPy as NP, right? So here you can see import NumPy as NP. When I say, okay, yep, import NumPy as NP, I import NumPy now. But if you have already imported at the top, then that's fine. Then you say, remember NP, because we import it as this, we must say NP dot all the method inside our NumPy module, right? Then we have array. So this is how you can create an array. So array, you use this keyword array, and now you put your input, right? So you can see this is an array, this is an array, this is an array. Yeah, so this is an array, this is an array. But the arrays here, they have different shapes. So let's look at, who can tell us the shape of this array, the first one, X1. What is the shape of the X1 array? Who can volunteer to tell us the shape of this X1 array?
1 by 2.
Huh?
2 by 3.
2 by 3. Now? Okay, 2 by 3, right. Now, what about x2?
It's 2 by 4.
2 by 4? Okay, let's look at it. Oh, I need to call this guy shape, right? So remember, shape, there is no open, like, remember there is no this, it is an attribute, not a method. So here we can call this guy, right? So this is the shape. Now, right, so we can also see, this is an example. Okay, right, that is not the example I'm supposed to give. I will drag it to the other location. So this is, we create, you can see we have our data which contain this is this, and now we can see this is the dimension, which is 2 by 3. We already number of dimension is 2. Shape, so here you can see is 2 by 4, right? But we have what is called ndim, number of dimension. Who can tell us what does that mean? Ndim, dimension, the dimension of array. What is the meaning of these two? Falalu, can you volunteer to tell us what the meaning of these two? What is ndim? Right, anybody can volunteer? Okay, so when you look at this, we have this, right? And I have this, right? And I have I have two arrays inside it, right? And now I use it data here to create array 2, and now this is array 2. Now when I call this array 2 ndim, which is dimension, it gives me 2. When I create this shape, it gives me 4. So if you don't understand, let's see again, maybe one can understand it. So here I have another one, which is a single array. You can see it's a single array. Now inside this guy, you can see when we say ndim, we can see, you can see it's what, 1, right? When we say the shape, so who can tell us the shape of this guy? Not the ndim, the shape. What is the shape of this?
5.
5?
Yes.
So, but one thing we should.
1 by 5 dimension.
Yeah, wow. Another argument take. So when you look at this, what shape return is what? What does it return here?
2 by 4.
2, 4. What is the name of this in Python? What kind of structure is this?
Tuples.
Yeah, tuple. So now look at this guy. Now, when we run this, look at what it gave us.
Anama is a tuple.
Yes, I mean for a shell.
1.
Yes. So for a shell here, because we have an array with only 1 dimension, right?
Yes.
But we have here you can see 1, 2, 3, 1, 2, 3, 4, 5, right? It can be accessed by this. So because it is tuple, we cannot write like number 5 only. We all know that a tuple, what differentiates a tuple is just this comma. This is a tuple, but this is only number 5, right? So this means that what you have, because the shape is 5, you will do this something. So whenever you have a single dimension like this, the dimension will be a form of a single number as a tuple. So that's we discussed tuple, right? We all know the difference between this and number 5, right?
Yes.
Saminu ka gane abin nan ko abin da nake magana nan wanda number 5 din nan kuwa? Saminu ka gane abin da nake magana?
Dan da ya gane ci gaba.
Iska ga gane ba ke da.
Ai ba haka ba. Wannan dina ne yaki wallahi, sai yi nake ta yaki.
Me?
Shi Numpy din. In na sa pip install sai ya ce already install ne ko menene, amma kuma ina abin sai yaki. All
right. So yeah. So you should all know that when we have this single stuff, it should give a single number. It should be this. So don't be confused. We will get the detail of this. So yeah, so we have what is called D type, which give us, so I will call to the NDIM and dimension here. Don't worry about the NDIM. So to create an ND array, we can pass a list tuple array like object into the array. So this means that to create a array, we can say np.array like this, right? And now I can pass, you can see here I pass what? A list, right? So when I pass a list here, you can see it will create what? Array. But can you pass not a list but a tuple? Can we do that? So let's look at it. Can you pass that? So when we have this, can you see that? So what this is telling you that to create an ND array, we can pass a list, a tuple, or array-like object into the array method, and it will be converted into ND array. So this is something we should know that this is what it does. So let's look at this, the explanation I wanted, the NDM stuff that I want to say. So here, if you look at the dimensions of an array, what does that mean? A dimension array is one level of array depth. Next set array, one level. So let me show you an example. You can see here I have a zero number, a single digit, which is 42. But here I have a single array, right, inside this array. Here I have what? Two nested, right? Can you see I have two nested array inside it? So if you look at this one, the first one here, it has what we call zero dimension because it is just a scalar number. The dimension, the NDIM number of dimension is zero. This one, the number of dimension, right? The number of dimension is 1. So when we run this guy, let me show you. So you can see the dimension of this NDIM, number of dimension of this is 0. Number of dimension of this is 1. So here you can see 0D arrays or scalars. We know in mathematics these are called scalars, right? Because, and also they are not arrays, right? They are 0D arrays. They are not, this is 1D array, right? The element in array, each value in array is a 0D array. So we can see that each value is a 0D. So this is a 0D array, but this one is what we can see here is when an array that has 0D arrays as its element is called unidimensional or 1D array. So this guy, an array, you can see this is an array, right? I say array, I open and create array. An array that has 0Ds as its element. You can see its element here as 0Ds, but because 1 is 0D. 2 is 0 dimension, right? So an array that has 0D arrays at its element is called 1D array, often represented as is it correct? This is not correct. Often used to represent matrix or 2D tensor. No, this is not correct. This is what the correct one. So you can see this one here is 1 dimension. An array that has, I copied this one wrongly. An array that has 1D array at its element. So you can see this is an array, but what are its element? This is 1D array, right? This is an array, 1D array. So any array that has 1D array at its element is 2D array. Can you see that? So this is 2D array. An array that has 2D array at its element is called 3D array. Let's look at this. So look at this guy. It is 2D array that serve at its element. You can see this is 2D array that serve at its element because this you can see the last. So what we should know is that this is the opening braces. Okay, let me change this maybe a better representation. Let me show you this. So if we take this guy, I put it this way. So you can see here, I have, let me represent. So you can see here, these are the element of this matrix, the element of this array. What are the element in this array? They are 1D dimension, right? 1D. This opening and the clothing is what create. So this you can see it. But when I have this one, maybe this, oh, it is something I took, right? When I have this, just want to show you it in a better way. So when I have this, so you can see here, yeah, I want to change the visual representation. So you can see this one here, that the elements are 2D array, right? So what this is telling us that if we have this information where we have an array that has 2D array, then it is these are often used to represent 3D tensor. So that is n dimension. So what we should know that at the basis is that when you have a scalar is zero and dim, and when you have an array with array inside it is 1 dimension. Yeah, so we see details of that. Other functions, so there are other functions. Now we have seen how to create array, ND array in with Numpy, but there are other functions that automatically create arrays. We have, for example, zeros. We use this guy. So this is np.zeros. So what np.0 does is just create an array with zeros in it. So you can see this create an array, but everything inside is 0. So sometimes we may need to create an array with 0 content. But what about this one? So np.zeros here, I said when I give this 10, it's just a single array. But here it means 3 by 6. Create a 0 dimension 3 by 6. So we'll see this. So here create an array 3 by 6. Can you see that? It create 3 by 6 array, right? So this is it. So we have an empty, which basically will create an empty array, but there is an issue with that. So so you will be seen when we go along, you will see being seen like np.0. It means this, we are just creating. So it is not safe to assume that np.empty will return an array all 0. This function will return uninitialized memory and thus may contain non-zero values. So this does not actually specifically create empty array. Because there are some kind of uninitialized memory stuff that are there, then it represents. So yeah, arrange is also is an array value version of built-in in Python. So you can see that we have arrange, which I already explained, is basically the version of range functions in Python that we know. So these are basically some of the stuff, but we all have some function that can be used in array. You can see this is used to create an array. This one is used to create once. So we can have another function here. For example, I can say once here, once here. So when I use this one, yeah, can you see it create once, right? So these are some of the stuff. If you look at the book, you see a lot of zeros, empty, like full, all this identity, identity, remember identity matrix, right? So when you use the method identity, would create identity where the diagonal are all ones, right? So these are some of the methods you should know, and you can practice them on yourself, how to use this identity, you can practice it. Right, so that is how we can create an array. So the first thing we now see is how can you create array? You can create array with a method with this guy array. This is how we can create array. But you can also convert input, anything that is not an array, you can use as array to convert it array. But we have other method like arrange, as we saw here. Arrange can create a matrix, can create an array. Yep, so we can have arrange here, arrange, which basically will create an array. Yeah, so any question before we move on to other stuff? Or anyone wanna talk something? Please ask question if you have. So yeah, so now we saw how to create an array. Let's look at some of the stuff we can do with array on data types for ND array. So the data types or D type, so remember in Python, what do we use in Python to find the data type of a particular object? So for example, here I say A is equals to 3. When I want to find the data type of A, how can we use in Python?
Type.
Type, right? So we can say type.
Then And bracket the number.
Yes, so this is how we find the type of an object in Python, right? But in Numpy, Numpy is not Python, right? It's on itself. So it uses different ways to find the type. So you can look at it here. I create an object, a Numpy array called array with arrange. But if I want to look at the data type, then I can say D type. So let's look at this guy. You can see it tells me this is integer 64. Can you see that? The data type. So you should know type, check the type of Python object, D type for NumPy. But what about if somebody say, okay, let me check the type of, use this function in Python, type, and now I give it the ND array, the array. I give it the ND array. Let's look at it. What will happen? Can you look? Can you see the difference? So can you see the type in Python that you use tells you this is ND array, right? ND array, but it does not tell you specifically what kind of ND array, right? You can see, but when I call D type, it tells me this is data in 64. As I see this D type, I know it tells me this is a NumPy, right? But when I call Python type on ND array, it tells me it's just an ND array, but it doesn't tell me the specific of it, right? So since NumPy, any question before we continue? So since NumPy is focused on numerical computing, the data types, if not specified, will in many cases be float 64. That is floating. So if, for example, here you can see I just create an array. I did not specify which kind of data type this array should be created. By default, it will be, since we are using numerical computation, it will be float 64, floating point number. But you can specify the kind of data type you want to create your array. So you can see here, I say np.array. I initialize the array, but I give the data type. D type is float 64. D type np.integer 32. Can you see that? So this is the way you can actually tell how you create your Python object by specifying the data type you are creating. So you can see here when we say this guy, this will give us, when we call this guy as well, we can see it gives us the correct results. Right? So this is how we can do that, right? Yeah. Any question before we can continue? Any question? Right. So if we can use S type to change something from one particular, so you can see here we have our R, which is basically int 64, right? Now we can change it to float 64 to different data type, right? So we can call this our object R and call this method as T. Can you see that as type? Then we can call np.float to 64, and now assign this value here, and now I can call float R D type. So this one, it's just like type conversion. We all know type conversion, right? In Python, how do we do that? So in Python, if I have a equals to 3, right? A is equals to 3, right? Now I can use a double A, right, to change this guy, to change A to double A. And now if I sign, okay, I don't need to do this. I can say, okay, double A. Oh, how do you do that? I have, for example, 3.45, for example, in Python. I can have int A. Right. So for example, here I have in float, right? In float, which is 3.5. In Python, we call the method here. We call, so you can see this, but in NumPy, we use this S type. Can you see that you need to call this on the object? So you can see the object is R type, okay, and you can see that. So this is how you can do that, right? Yeah. So here we have, this is float, and we can call np int32 to do the type conversion. So this is how you can do type conversion. We already know how to do that in Python. Yeah, we do typecasting, but also
but
if
I
you
thought
have,
also,
yes, yes,
I
go.
thought this Python doesn't have double as data.
Yeah, float. So when you
All
call
the
float,
Numpy has.
I want to say float. So when you call float, yeah, I want to say
trying
float.
to confuse my little knowledge.
Yes. So I want to say float. So when you call float, that is what we'll do. It's not double. Right. So if you have an array of string, so here you can see we have string, we can, and you can see it's in string, we can change it to float, right? So this is the type conversion as well. So you can see here, we use float, not float 64 or float 32, right? Float. Now, which is float in Python, right? Float is for Python, right? Float is in Python, right? So everything that is specific to Python, if you call it in Numpy stuff, then that specific Python is now overwritten by Python. So this will use Numpy specific, not Python specific. So it is a float for Python, but you call it on Numpy object. So this will now be, you will use what we call this method has been overwritten to use the Python, the Numpy stuff. So even if you use this, it will use the Numpy stuff. So you can see we do this. So you can see, yeah, this is it. Numpy aliases the Python types to its own equivalent data type. So when you say Numpy plot, then Numpy will use its own equivalent. It will not, what do you mean by alias? Alias is like match past the name. If you say alias plot, Numpy at the background will automatically convert this plot to means plot 64. So that's what we mean by alias. So if somebody did a mistake, it will automatically convert it to this, right? So, yeah, any question before we continue? And also you can basically use another object data type. So let's look at this guy. So you can see here, I create a Numpy array using array integer. You can see this is a Numpy array. Now this arrange, because I put from 0 to 10, is giving me 1, 2, 10. So we can see this object, the data type of this one is what? We can see the data type of this object is integer, right? Can you see integer 64? So I can use this in the data type of this guy to create an object. So you can see here, I said, okay, I create an array. No, not this guy, I already created. I have an array of floating point numbers, but I want to convert it to integer. So I can call the, I want to convert this integer to float. So I can call this object. I say, okay, what is the type of this object here? So convert as type, caliber, it is floating point, the type. This will return float, and now this will do what we call the type casting. So here it means you can use the object as well, or different type. There are shorthand as well. So here you can see Numpy empty 8 data type U4. What does this mean? So there are shortcut. So instead for you to write integer 8 or unit 8, you can use this shortcut. Int Cs, you can use this shortcut. So this is what we mean by plot 16, half precision floating point. So it means it. This means that it's using half precision. When we say half precision, it means it's using I think byte, a single byte, I think. But float 32 is single precision point. It's using with double precision. Plus 64 is standard double precision. So these are some of the requirements. Maybe when you are doing your mathematical stuff, you may specify what you are going to use. This basically what it does is it tells you how these data types, it tells you how large we want to store. So if we are using int 16, it may not store the number that float 32 will store. If you are using float 32, it may not store large number as float 64. So these are different kind. You can see you have float 128, a standard precision floating point. So you can use anyone. So we will see that, and you can use this shortcut, which is right here. Any question before we continue? Malama kin gane abin da kike question ɗinki about this float stuff? Malama Sa'adat, kin gane question ɗin da ke akan float, this float?
Na'am, doctor.
Kin gane?
Na gane.
Yes.
Na
So
gane.
yeah. Okay. Now we also have arithmetic. What we can do arithmetic in Numpy. So what do we mean by arithmetic? We can do everything. We know that Numpy is used for mathematical operation, for numerical. So we can do multiplication. Now, for example, I have an array. I created it here. I can say, okay, I can multiply arrays. So I multiply the arrays now. So this, because I multiply the two, this number will multiply by each corresponding one. I can do subtraction. Yeah. So this NumPy support this kind of operations. You can also do division. So when I say 1 divided by array, this means that one will, every item here will be we say 1 divided by this, 1 divided by 2, 1 divided by 3, 1 divided by 4, 1 divided. So this is kind of the operation that it supports. So you can see 1 divided by array. So you can see 1 divided by 1 is 1 already. 1 divided by 2 is 0.5, right? So this is you can do a lot of this operation. We can say array times 0.5. So this will actually multiply each number by 0.5. So this means that you can see here we have 16. No, where is the array? Yeah, 4, right? This is the array. We can multiply each number by 0.5. 4 times 0.5 will give us 2, right? 1 times 0.5 will give us 0.5, right? So you can see when we do them, 0.5, it gives us this. So these are some of the operations we can know. You can do greater than sign. Can you see that? So when I say this greater than this one, you can see this will give me false if 1 is not good. So these are a lot of operations that you do in mathematics. You can do them with a NumPy array. Any question before we continue? Any question? Okay, right. So let's look at the basics of indexing and slicing. So now we understand NumPy array. We want to continue with how we can index a NumPy array and how we do slicing. Remember, we do this indexing and slicing in array in Python list. So they have some kind of similarities as well. So let's look at how we can do that. So you can see this is a 0D array. So we have this. Now, if I want to take any number here, I can say array, or just like the way we do in list. So you can see here 0, 1, 2, 3, 4, right? No, 0, index 0, 1, 2, 3, 4, 5, right? So you can see this one here. I have array of 5. It gives me this, right? So look at it. Now I can
sorry, Amawana, is it not returning? Is it returning the index for the actual?
No, what I'm saying, here we are using index to return the value. So now I want to return 5. Okay, maybe this may look confusing. Maybe let me change the, oh yeah, this may look confusing because whatsoever I gave. So let me say, let me return the index of 1. You give me 1 already. So when we are doing slicing, indexing, we put index here. Now, what is the index? What is the index? Now, assume I want to return 5. What is it? It is index 5. What is it? Is index 5?
6.
6? Index
Yeah.
6. Okay, how do you know it is 6?
Okay, the indexing begins from 0. 1, 2, 3, 4, 5, 6. If you start counting from 0, its index will be 6.
Will be what?
Okay, it will be 5 because you are counting from 0, 0, 1.
You know, indexing start from 0, right? So 0,
yes.
0, 1, 5. So when you put 5 here, the index, it will return the number. What is the number in index 5? Is 5.
It's
right?
going to be 5.
Yes. So, but this example,
I think what got me confused is because you are using, I mean, the numbers are the same as.
Yes, exactly. Yeah. So let's change that. Maybe XY, something like this. Then we say, okay, np.array, right? So we have this guy inside, and we have this. and I have this guy, and maybe I have some numbers inside, and the numbers can be 1, right, and can be 8, and can be 7, right? So yeah, so something like this. 0. Okay, so something like this. So now if I have this guy and I say, okay, what is this? So if I want to slice it, I can say XS, Y, right? And now say, okay, now if I want to index, I want to index 8. What do you think? What should I put, Simon? If I want 1. So when I put 1, so let's look at what will happen. Can you see? So this is it, right? So yeah, so that is called indexing, right? But we can also do what is called slicing, right? What is slicing? Who can tell us what is slicing? Simon, can you tell us what is slicing? Hala. Wannan tafi ƙarfinka ne. Okay, so here we have this guy. Slicing actually takes some part from your list or from your array. So here we said from 5 to 8. So when we slice this, so you can see slicing have starting and end. This is what we use. So you can see, give me from position 5 to position 8. What are there? 0, 1, 2, 3, 4, 5. So from position 5, can you see that it starts from 5 to position 8? 5, 6, 7, 8, right? But remember, the last one is not included, so it will give you this array. So this is called slicing, right? But taking a single number is called indexing, right? We already discussed that. We know this in and you can also assign a number. So here you can see from 5 to 8 replaced with 12. So this, let's look at what will happen. So we can see from 5 to 8, that is from here to here, replace them with 12. So you can see here, everything now is replaced with 12. So because you say from 5 to 8, 12, it means because we do what is called broadcasting or vectorization, the value are propagated or broadcasted, hence for the entire selection. So it means that you can see here, I do not provide 3 numbers, but I just provide 12. I say from 5 to 8. Then it all the numbers at this middle, they will be, this is what we call broadcasting in Numpy, and we'll discuss this. So Numpy do what is called broadcasting. We'll discuss this in a little. Right, an important first distinction from Python built-in list is that array slice are viewed on the original array. This means that the data is not copied. So this is one of the great difference between Python built-in list and array. Let's look at the example. So in Python, list, when I have this, I say A is equals to maybe like this, which maybe is contain numbers, right? 1, yeah, so 5, right? So this is maybe a list. Now you see, when I say, okay, if this is a list, and I subset this list, I said, okay, B is equals to A, I subset the list maybe with 1, 2, 3. So I subset B 1 to 3 here. So what will be the B? Who can tell us what will be the value of B? Eh? What is the value of B? Huh? What will be the value of B?
I think it's going to be 5 and 7. 1, 2, 3. Go.
Battery, Dr. Samin.
Now, battery.
Battery. 3 ba shine first ba shine index.
3, 5, and 7. Go.
Yeah, the 3. Yeah.
Yeah, but if we look at this one here, we can see A1 start from position 1, 0, 1. That is, you start from 3 to 3, 1, 2, 3. 7. But remember, the 7, the last one is not included.
It's not included. Yes.
So it will stop at 5. So yes. Right. So
what
So what this means is that, okay, now I have this. So what about if I have this? Bismillah. So what about, this is a list, right? Now let's look at our array that we created using Numpy. So if I have this array, this is my Numpy. Right, this is my Numpy array, right? Now, when I do slicing, I slice some part and now store it in what is called array slice. Let's look at what the slice I did. This is the slice, right? This is from this 5 to 8, I assign it to a new variable array called this. Now, array slice, this one, first position, I assign a number. I change the number. No, not this one. Let me show. Array slice. So this is very important. Let's carefully understand what this means. So look at what I mean. So here I have an object, right? Array. This is the array, contain numbers from 0 to this. But I say, okay, let me take this part and assign to a different variable. So that is this license. I assign to this. I say, okay, now you remember now if I want to change the first item here, this is how I change it. I do this, right? Remember a list, right? So now first position, I want to change this guy in the first position. I want to substitute this value. Let me run it. Not first position, second position, because it starts from 0. So when I say 0 here, it means I'm changing the post position to this number, right? So let's look. Can you see that? Now you can see I am now doing, because this section that I copy, this one I substitute in this part, right? It's like copying, but the problem now is this. Let's look at the original array that we copy, which is array. So if you look at this one here, the original array, let's run it and see what will happen. When we run the original array, the problem is that you will see that its content is also changed. Can you see that? The content of this original array changes, right? The contents of this original array change.
Yes.
Can you see that? But remember, we have not changed, we have not touched it at all. Only we copy some part of it and assign to another variable. When this is the array, can you see that?
Excuse me.
Yes.
Excuse me. How did you arrive at this 1, 2, 3, 4, 5? Because me from array.
Okay. Yeah. So this is let me go back. Web array. Yeah. We have array. Just it is there. I think there. Yeah. This is it, right? Array. So why do I create the array? Let me go back. Excuse me. Oh yeah. So this array is basically this. Let me show you. We use array. So let me come from here, for example. Maybe you understand it. Okay, so maybe let me repeat this. So this is how it done. np.array range. We put 10 here, right? And now when I call this, right? So here we can see we have this. I don't want this format. Where do I define the other one? This is the array. This is the array we are using. Oh yeah, this is the array, right? There's something I did there. So Simon, can you see the array I was talking about?
Yes, I can see it.
Yes.
Now you have not. Okay, continue there because my question has not been answered yet.
Okay, what is your question?
My question is, you see where we have that 12, 12, 12 repeated.
Oh, okay.
Now it is now replaced by 1, 2, 3, 4.
Yes. So that's what. So okay, let's go. So let's still see that. So here I have my array. Let's continue with that. Can you see we still have this, right? Now I want to slice this array. I want to slice it. We know what the meaning of slicer, right? Now I want to slice some part of it and assign to another variable slice. So let's slice it. Now we slice it here, right? Now, when we slice this array, now let's look at, say we say, okay, these slices that we did, there is something that we already did at the top. So here we remember, this is what we did. Remember here, these are this. So here, this is it. So what we explained this one here, this 12, the part of array 5 to 8, we assign number 12 in it.
I don't have problem with it.
So that's where this 12 comes.
Go down.
That is where 12 comes. So now still I need to run this so that the bottom reflects. Okay, yeah, we have 12, right? So okay, so still here, this one will be our, right? So now I say, okay, this section, assign it to a variable called slice. Now you can array file, so I assign it to a variable called array slice, which I slice. Can you see it? Now you can see that now, okay, let me delete this one. All right, so now you can see here I have my array slice. This is the array slice. But I say, okay, let me this first position, let me assign one number in it. I want to update it, update the content. You can see that now my array slice is different totally from the original array. So let me show. So the original array is this. This is it. This is it, right? Now the one I sliced, this one array slice, is this, right? This is it, right? But the only relationship between them is that array slice have been copied from the big array. So, but when you update the small array, what you copied, the copied one, when you update it, now I want to update this, the copied one. I want to assign one number to the copied one. Let's look at what will happen. So I assign a number to this copy. Can you see that? Now the copied version, I assign a number. Now the issue is, do you think the original array will be updated based on this update that we use on the small array or not? And again, let me update let me just leave it. So when we call the original array, call array R, right? Let me call this. You can see that this original array is affected. Can you see the 12 there that I updated in the copied version has changed?
Yes.
So this means that the point they are trying to say that this is the English. Where is the English? An important first distinction from Python built-in list is that array slice are views on the original array. When you do slicing, because here is a slice we did, we slice the original and put it in another this, then this slicing is a view of original. Whatsoever you touch on this slice will be affected on original. Unlike a list, whatever I do on the slice version will not. So here, this is a list, original one, and this is a slice version. Let's see whether when we change the slice version. So look at it here. This is a slice version, right? The slice version contains some numbers 3 and 5. But let me see whether if I can update the slides version. So let me say, okay, the slides version, the first position, 1 position, assign 4 or assign 1 million, this number. Let's run this guy. So yeah, so let me run it, B, and see what is B now. Can you see the first position now updated with 100? So let's look at the original one, A. Will it be affected? So A, will it be affected? Kaga A gaba ɗaya tana nan originally yanda take.
Yes.
Do you understand what I mean?
Yes.
But in NumPy, one of the things we should know is that an important distinction Python built-in list is that array lists are viewed on the original. This means that the data is not copied, and any modification to the view will be reflected on the source array. But do we have any question? So yeah, so this is something that we should know, that you may try to copy this an NumPy array, but you are not copying. You are just copying the view. So if you want to copy an array, instead, what you need to do is use this copy. Can you see this keyword copy? So when you use copy, it means you copy you can see that here the slice, the slice, you copy it. So this means when I do this, I change the slice and now call the original. Now the original is not affected, even though I update the slice. So this is one thing we should know. All right, I think we are getting, the time is over. Individual element and array can be recursively. I think maybe we can stop here, I think we can stop here and continue tomorrow. Yeah, any question? Yeah, we can stop here and continue from there where we stop tomorrow, possibly if we can finish NumPy. So I think what we should do is that please, NumPy, NumPy is actually one of the strong thing that we should be using. You cannot do your deep learning. So in deep learning, when we go, we'll basically be seeing what we call tensors, which are basically extension of this stuff. So extension of this NumPy. So NumPy is really, really important. You have the book, you can read it. Here our discussion facilitate more understanding. Yeah. Any question?
Sir.
Yes.
I have installed all this NumPy and the libraries using the pip. So is there any difference between using pip and Conda for installing any of the libraries?
No, there is no difference between, so they do different purpose. You can use pip, you can use Conda, but yeah, Conda has its advantage over pip, that is all. Yes. So when you also install package using pip, continue using pip to update it, and yeah. But yeah, so the only thing is that Conda is a environment manager. You can create environment with Conda. You can install packages with Conda, but with pip, you can only install packages. You cannot create environment with pip. So yeah, but you can install with pip if you have been using pip. So what is recommended, like in previous session, we said that try to do installation with Conda, but if the package does not support Conda, you can use pip. Yeah, any question before we continue? We go. Yeah, so please read the chapter for yourself, and that's an ask question when we come to the next session.
Doctor.
Yes, sir.
Wannan environments din the deep learning da wani ne zamu installing ne? Data science, deep learning, ko duka kawai mu zuba environments ne? Reinforcement learning.
Yeah, so in deep learning, yeah, so you can create a single environment. For instance, now you are not doing any project, you can create a single environment maybe to install all the stuff you have. Yeah, so for example, for me now in this environment, data science environment, I have like my NumPy, I have everything, I have PyTorch, I have, but if I want to do specific stuff, I will create a specific project where I know I will share the stuff, I will create a different environment and do that. But the idea is that So as I said here, we started doing our group. We were doing deep learning session in our one group called NLP House NLP, which I'm leading. So in the group, we were basically all of us are advanced students. All of them are PhD students, and we started looking at the deep learning with PyTorch. Where we will be doing, we'll go through it. We started discussing chapter 1 today. So if you are interested in the deep learning, in this session also, as soon as we finish this one, we will start doing deep learning. But the first thing we need to understand NumPy, these basic things, then we can move to that. But if you think you are comfortable, your Python is good enough, you can join us the deep learning session. We do it Saturday and Sunday in the morning, 8 p.m. 8:30 na safe, 8 na safe da rabi na safe zuwa 9:30. That is it, how we do it. So we started the first session. We have the recording. If you're interested to attend, just let me know. I can add you to the group and also share the recording. Yeah. Okay. So if there is no further question, I think we can stop here and we can meet tomorrow. All right. Bye-bye. Ciao, ciao.
Bye-bye.